Hey everyone, my name's Taylor Smith. Welcome to Hands-on Machine Learning in Python with Scikit-Learn. I will be your instructor for the next 3 to 4 hours throughout this course. This course is going to be geared towards a practical approach towards machine learning in Python, specifically with Scikit-Learn and using tools such as Pandas and Jupyter. I'd like to give you just a quick background on myself. My name's Taylor Smith. I've been a data scientist for 5 years at the time of this recording, and I'm a pretty active open source contributor. I've included my GitHub link down here. Feel free to go out there and contribute to some of my projects. I would love that. I've worked in both the telecom and insurance industries pretty extensively, and most of my specialties these days lies in recommender systems, although in the past I've also dabbled pretty heavily in vehicular telematics, so anything sensory telematic-wise. We have 5 different modules that we're going to go over, and varying levels of depth and specificity, I suppose. So the module you're currently in, getting started with machine learning, is going to be the most shallow. The first few sub-modules are going to be geared towards getting your environment set up, getting started with Jupyter Notebooks, and then just kind of a lay of the land. And then as we move through the next 4 modules, those are going to relate kind of to the chronological order of how you progress generally through a machine learning problem. So exploratory data analysis, which I'll call EDA, the model development, the tuning and selection, and then finally deployment. So we'll get into all of that. And I would just like to point out that we'll be diving into one notebook pretty heavily, but we'll be jumping actually between 2 or 3 throughout the course, just so you can see different data sets and how different nuances of data might become relevant for certain techniques that we introduce here. We are aiming for those who have had exposure to object-oriented programming. We're not going to be doing a whole lot of class development, or we don't have time or scope to dive into the background of inheritance and encapsulation, but we will be using them for when we develop some of our custom machine learning transformers. So it's good for those who are taking this course to have a background in object-oriented programming. Again, it's nothing required. It'll just be good for the understanding because we don't have time to dive into that. On top of that, we make the assumption that all of the students have taken basic or intermediate courses or have had exposure to Python and statistics. We're not going to be doing anything specifically related to heavy statistical testing or anything like that. We'll leave that for the actuaries, but it will help when we talk about concepts such as measures of central tendency, how far an outlier might fall, etc., stuff like that. And finally, we're looking to reach those who've had little to no experience with machine learning and are looking to dive in at a very basic level all the way up to implementation and deployment, ideally within their company, because this course is geared towards those who are looking to use machine learning within industry and not for research. So that brings us to this page. I would like to disambiguate what this course is aimed towards and what it is not. I've already mentioned that we're aiming for practical machine learning for industry purposes. Best way I can put this is if you think about a problem that you would apply machine learning to and you cannot think of where the business value might lie, then that's probably not the direction we want to take. This course is all aimed at not only do you want to build a successful model that can break down all of the important attributes, but how can you communicate your results up to your executive leadership, those who are stakeholders in the project, and finally, where's the value derived? That is what we are aiming towards. We are not a theoretical course here. We are not going to be going over heavy math details. You'll see several equations embedded in some IPython notebooks, but it's nothing that you need to really grasp all that well. It's more supplementary. And then finally, this is not going to be a silver bullet for any machine learning problem you might encounter in the wild. There's a theorem called the no free lunch theorem, which is very much how we abide here. That states that there is no one algorithm that will solve every machine learning or any problem for that matter that you encounter. So every algorithm has its day, and likewise, everything you see here is very good for general purpose understanding, but it will not solve every problem that you have. We're aiming to give you that introduction and that practicum, and then you can take your knowledge and move forward with that. So that said, you will see a lot of collection of modeling best practices. I'll go into a lot of the reasoning behind some of the rationale behind some of my code, and then perhaps you have a better idea, but I will give you what I perceive to be best practices as an open source contributor.